Hello everyone, hope you're doing good. Welcome back. Apologize for the other one which was six. I didn't made it. I didn't made it because it was too dangerous. The specials to kill me, got me. But let's go for the exercise. So this was my answer. You know, I mean this one. The first step was like this. You just have to basically I first write the ampere law. Then I knew that it was like a sheet of parallel wires. It means like a solenoid. So I used the formula for solenoid. So it's just the amount of a number wire. That's what it's called for. And okay, Step two was like so I took just the formula for solenoid. Then wait a minute. Then I look at this drawing, When you look at this drawing, you see that I choose a path, because the solenoid with an integral, you have to choose a path. You can choose it like here, here, doesn't matter, here, but I choose free for structure in the middle. Okay, so basically, I have my B above my plane and then B under my plane here, and it's always in that kind of situation you have to do like this. And when you choose your B1 above, you have as well have to choose your length, the length for your above and the length for under, the A. That's why I write it 2 times. And what can I say? So when you know that, you can say that wait, before this you have to know that B1 and B2 magnitude is the same, because that's outside of the two planes, and um and yeah, and in the end you have this one B. Then I did B times 2A, like it give me this one. Then you have just to calculate like this, and then before I go to the third step, you have to look at this symbolic drawing thing there. So I knew that it was this. So basically, I knew that my B is gonna move like this, in this direction, and that's why I drive it like this one direction, in my loop, in my path, And yeah, okay. That's very important for the third step. Okay, third step. Does finally the question on this thing. Write an expression for B direction infinity of D. So my B direction or the magnitude field at distance D above. So yeah, basically I underline this word because they only say the above, above. So I just so don't look. I mean, don't look at B2 direction. Direction. I repeat. Just look at the direction of B1. My arrow there, over there, is going in the negative direction. And that's why I choose the minus symbolic, and also because they are just moving they're not moving there, I mean B1 just in the x direction, so x e same, so e direction. That's why I choose this one. Okay, let's go for the next one. J'allais bugger. Okay, right now we are in the second exercise. So this second exercise being like this. So basically what you have to do is just find the C1 and C2. So here is like this. Here is like wait, just the information about C1 and C2. I will use another color. So C1 and C2 is with this equation and this equation. So G1 is basically G1. So this is like just the inner, yeah, inner, I think, yeah, inner, and then you have to second equation order, Okay. So first step is just, you have to use the current through through the conic structure. I did this like I used the integral from 0 to 1. If you can see the drawing, then I just take the G1 I mean like this one, then I did times basically this is just the density, density. But then you have to use the trick. I mean this thing there times the air, and then it will give you this answer. But it's not finished. This is just equal to E. Damn, you know what I mean. So then you have to do this like this to find the C1. Then the second step is this. Second step say also to find the C2 because in the beginning I was asking for the C2 also. So what I did, I did minus E0. Why did I put a minus? Because I'm just referring my reference is just to look at this arrow, it's going in the positive x-axis, and this other one is going to the negative x-axis, and what can I say? Yeah, just for C2 is more the it's more the gift is okay. This is the so you can also say it's a mass of I don't know. You can say it's a thing it's yeah, may. So that's basically C2 is this, C2 is this one. I think, but wait, what I did here is just you have from R2 and then R3, and then you have to do CO2 times my R. But my R is equal to you will see, it's just like this R is basically R1 because it's just difference between R and 2, 3 and 2. But you will see what I mean with this third step. So third step it was like B times the L is equal to mu times E, then mu 0 times basically what is they ask is just this. They ask just from 0 to my R. R is equal to R1, They just make it a little bit difficult for nothing. So yeah, it's just basically the same formula like this, So I will write this because E is just an E total, and E total we already find it. It was like this, That's why I just put this also here. But then we also already know that that E0 was equal to this one. So you can also see that this one is equal to this one, this one and this one. And then I did just 2 over 3 mu times P times R to the delta equal to 3 times E0 times 3. Basically, this is coming from this. Yeah, this, When you have this one, you can do this. Like then you have wait, then if you have the last step you say that you have to do. So we know that this is equal to this one because B is constant and then DL is your track, So 2 times PR, and then it will give me 2 over 3. 2 over 3 was already there. 3 over 2, 2 over 2 times times just calculate the thing, and then it will give you this one, and you just should look at this one. Okay, let's go for part B. B, 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 B. Okay, for part B, you just have to do like this. So basically they say R1 and R2. So R1 is touching here and R2 is touching there. So it's for the inner, you know. And yeah, just inner. Mm, mm, mm. Yeah, just in the inner. Just because it's just in the inner. Okay, so you can see this here. So R1 was in the other. R2 is in the inner. So basically you have to look at this one that's in the inner. And if we give you, so this is the ample flow, and this is just it's just the B times the on track time is equal to the mu times E0, and so can find your B manifold. It's just this one. Okay, let's go for the part C. Okay, part C. Part C is here. So I'll show you. So this is just a part C. So basically they say R2, R2, and R3. So what I did is just looking for R2. So if you put this like this, you can find, I don't want to talk too much, but this, if you can do this, you will find this one, you know. Now part D, part D. Oh yeah, I forgot to say that C2, you know, you have just step one and step two, you obviously do to need this for calculating A, B, C, you know, and then D also, because C2 we already know is equal to this thing, you know. So you can easily find your answer with this one. If not, leave a comment and I will send you something. Basically, for part D, they say where is R3, so R3 is here. Damn, where's my flu? So R3 is here, you know, from this one. Then you have R is much greater than R3, so it's basically outside where there is not a magnetic field, you know. So that's why I chose 0, because we don't have it's a thing that greater is than R3. Is because there is this just vacuum. There's not a wire. So 0. So basically it is like this. B is equal to 0. Equal to 0. Okay, skip. Let's go for exercise 3. Okay, right now we're on this third exercise. Excuse me for the second exercise, it was too much. Let's get it. So first step, you just have to, you know, calculate the force of a wire, you know. So this is a formula you have to know. We have to take this one. This one is much important, you know, relevant. When you have this, do step 2, and then you can do like this, you know, and then you will find your answer. Okay, let's go for the fourth exercise. Let's get it. Oh damn, I forgot something. Excuse me, I forgot something. The 0 .250 meters. Damn, excuse me. It was the 0 .250 meter. It was from here because they say part of a single rectangular loop of wire. Part with an in the figure is situated inside a region. The only thing that I see that this one is inside this region. This little detail, you know, saying. Okay. Okay. So for this one, you just need to one step for A. So what you have to do is just the magnetic flux. You have to use this formula from there. So from B first, then from B plus A, from this one. I mean this distance. Eh, this you know what I'm saying. So then you have this region, then you have to, so B is equal to this thing. Then you have A times the R, it will give you R, because R, um this, yeah, it's usually dA. So basically R times dr, dr. Then you have this formula. So this was mu times E over 2P times ln R. You have to put this one. Then you will have this, and then you have part B. Right now we're on the fourth exercise. The fourth exercise, I divide it on 3 steps, but not in the same exercise parts. Like I will show you what I mean. Damn, but so this one is from part A, and part B you will see this one. Then you will see you will see. So for part A, what I did is I using the magnetic flux, and you can see I just take the distance between this one and this one, and then B plus A from this one to this one, and yeah, then I just did it like this. Then you have A times dr. It's basically so you have dr, width and height, so yeah, dA. Then you have times E times A divided by 2P. And yeah, that's how you find this answer. Maybe that's good. For B, just have to do like this. It's much longer, but I try to write it in the short form. Basically, you have to base on this first equation. So the AMK is equal to the minus D magnetic flux, because my loop is going away from my wire, is and like we can find this answer for B. Then you have, we're going to do like this. No. Then you have C. Oh, right. Okay, I will hide this for a moment. So here, je dis quoi? So C does include induced current flow cloud. Okay, so you have to choose clockwise or counterclockwise. Actually, clockwise, and you just have to, you have a wire, if a loop, you just have to use your right hand, and it will be into the page, huh? I mean, you will see this. Damn, wait, come on, see. You will see this. It means that my B is gonna my B is gonna move like this one. Yeah, like this one. But yeah, doesn't matter. Mm, okay, part D. Part D is that one is this one part D. So basically, you have to calculate the force. And what did it say? Assume that R is a resistance of the loop. Okay, so yes, just use this one because we already know what E is. We already know what the velocity is. I mean, this one is just equal to the velocity. You know, was velocity, and normally you have everything to calculate this one. Okay, exercise 5, 5, 5. Okay, almost finished. Okay, right now we are in the fifth exercise. So let's get. So yeah, first step, what you have to do is use the general formula for magnetic flux. So this is equal to B times A. So magnetic field times area. It will give you this one. But why did I put this NP and NP? Because we are basically um basically working on the Premiere. I don't know how to say this, but we can see primary call and secondary call. But most of this is the what we have given. Yeah, what we have given is the NP. So what we have to do is just NP. Then you have to do this like that. Then minimum time there is the current that it was given here. I have to use this. Then P, because we have here diameter, and they say you have to work with the D, so P times D square divided by 4 will give you this one. And then yeah, step 2. Step 2 is when you finally find your magnetic flux, then you have to search how we can have the EMK. So basically the spawning of the so what you have to do is just the the how amount of codes times the magnetic flux differentiation, yeah. Then it will give you this one. Just don't forget to say that this is just equal to this one, and this one part is just constant, constant. But we just have to derivate the sinus function, and you will have this one. You will basically have this one and this one. You will see. Do just the derivate from this, and you will get this one. Normally, that's the way to do this. If you can't find this, I will write this on the comments. Okay, at this time there was not Tsukuyomi, sir. Just the time to. Okay, I hope you enjoy it, you understand it. If not, put some comments. Peace and love. Ciao.